I am Stamen Gotchev. I'm 22 years old from Sliven, Bulgaria.
I am Illief, 22 years old from Montana, Bulgaria.
We are studying Geodesy at University of Architecture, Civil Engineering and Geodesy in Sofia. We will present you a satellite-based rainfall monitoring dataset specifically designed to support the early detection of drought around the world. Developed as a partnership between the USGS Earth Resources Observation and Science Center and the University of California Santa Barbara Climate Hazards Group, this new dataset allows experts who specialize in the early warning of drought and famine to monitor rainfall in near real time at a high resolution over most of the globe. Monitoring rainfall from space with modern weather satellites has become a robust, widely practiced technique, but establishing a reliable context for relating space-based rainfall observations with present-day and historical ground-based rainfall data has been difficult. The new dataset, named the Climate Hazards Group Infrared Precipitation with Stations (CHIRPS), reaches back to 1981 to place rainfall observed from space into the historical setting of over 3 decades of collected rainfall data at ground stations worldwide. CHIRPS data can be incorporated into climate models, along with other meteorological and environmental data, to project future agricultural and vegetation conditions. Explicitly designed for drought monitoring, CHIRPS is already being used to identify possible hotspots of food insecurity. Much of East Africa is still recovering from a series of poor rainy seasons in 2008, 2009, 2011, and 2012. Food prices remain high, especially in South Sudan, where civil war has led to the displacement of more than 1 million refugees. Kenya relies heavily on highly productive farms located in the Rift Valley by Lake Victoria, where abundant spring rains usually support high crop yields that feed millions of people. This year, however, the CHIRPS dataset has identified a very poor start to the growing season. CHIRPS' long historical record indicates that this April's rainfall was the lowest in 34 years, about 2 inches for the entire month, less than a third of the long-term monthly average. This information has been passed along to the U.S. Agency for International Development Famine Early Warning Systems Network, prompting on-the-ground assessments of potential crop failure. In addition to providing high-resolution, near-real-time information to support early warning, USGS and UCSB scientists are also using the CHIRPS data to explore recent trends in rainfall. This information can help guide climate-smart development. It can also help water managers, hydroelectric power companies, natural resource managers, and disaster relief agencies to prepare for a changing climate.